Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last video I demonstrated how to test this standard definition CRT color TV horizontal deflection driver transistor MD2009. Base to emitter resistance is inbuilt. Pre-stick diode, body diode or freewheeling diode is connected from collector to emitter. Basically it is NPN transistor, 7 ampere base current, 10 ampere collector current. So its gain is very low and it is used for staircase switching to make a ramp and fast cutoff. So that is reason it is using 60 ohm resistor at base side. Some transistors are connected with external resistor, but this transistor is using built-in resistor for best results. While testing, I demonstrated how to test this transistor and I received a comment. Can you explain when we test with resistance mode and we test with diode mode, the readings are different? Let's check that question condition. It is NPN transistor. For any NPN transistor, we test base to emitter and base to collector. In this condition, there is a resistor that is connected between base and emitter. P positive, red wire, red test lead at base, black test lead at emitter. Here it is showing 58 ohms. If I will swap the leads, the same, because we are testing this resistor. We are trying to test this channel, but this resistor is in parallel. Now if I will test in diode mode, okay, let's check in continuity as well. In continuity it is same, but if I will check in diode mode, it is showing 0.089 volt. That was resistance and this is voltage, the voltage drop across any component. Here we connected red test lead at base, black test lead at emitter. It is supposed to flow current in this channel, but there is this parallel path. That is reason this low resistance is causing 0.089. The second thing, why there is difference? Maybe in some multimeters, diode, continuity, resistance, same reading, maybe. But here in this multimeter, it is using different current levels to test resistance, continuity and diode. Milliampere. First I will check current in diode mode. I will set this multimeter to measure milliamperes in DC. In diode mode, it is using 1.63 milliampere DC test signal. If I will check resistance, 120 microampere or 0.12 milliampere. Diode mode, the test signal was 1.6 milliampere. Here just only 0.12 milliampere, that is 120 microampere. Okay, let's set range. In low resistance, 120 milliampere. In kilo ohm, just only 30 milliampere. 999 kilo ohm, that is less than 1 mega ohm. That time the current value is just only 1 microampere, very low test current. In mega ohm, the current is very low, we can say in nanoamperes. So this multimeter is not measuring that current. 99 mega ohms, the current is not visible, that is very low current. Okay, let's check continuity. In continuity, it is also using 120 microampere or 0.12 milliampere. But in diode mode, 1.63, so it is higher current. That is the reason. When we apply low current, that time this resistor will make voltage divider network with the resistors that are present in this test instrument. When low current, few millivolt will drop and it will convert that value to measure this resistance. So that is reason it is showing 60 ohm or near to 60 ohm resistance. So this difference in the test signals, that is 0.12 milliampere and 1.6 milliampere, is causing to show different values. If I will check with this multimeter, resistance, it is showing 58.8, the same, the second multimeter. In reverse order, the same. Now first I will check in continuity. In continuity, it is also 58. Now I will check in diode mode. The same. It is showing 0.059. That multimeter was showing 0.08. So its test current is higher than the other multimeter. This multimeter, okay, the second thing, now there is another difference. Now we will check test voltage. Before this we verified test current. Now we will check test voltage. When we use ohm range, this multimeter applies 0.28, we can say 0.3 volt, 300 millivolt with 0.12 milliampere current. So this is test signal. In this multimeter, 0.26, 260 millivolt with 120 microampere current. In continuity, the test voltage are 1.7 volt, current 120 microampere. In this continuity testing, the test voltage are higher than the resistance. But when we will check diode, semiconductor, the voltage are 3.94 volt, current is 1.6 milliampere. So this is the difference in the voltage and test current. Here in resistance mode, 0.3 volt, 0.12 milliampere, 1.7 volt, 0.12 milliampere. Here 3.9 volt, but current is high, 1.6 milliampere. Why? If it will use low value current, that time some components will not be tested, because if the current will decrease than the junction threshold, that time it will show open circuit. That is reason In diode mode, multimeters use high current with compared to resistance mode. Let's see this multimeter. When we are in a resistance mode, this multimeter is providing 2.7 volts. This multimeter was using just only 0.3 volt, but this multimeter is using 2.7 volt. We will check current as well. For continuity, it is using 7.2 volt. Now there is difference. For diode mode, 7.2, the same. Continuity and diode, it is using 7.2 volt. But here for resistance, 2.7 volt. So this is difference in both multimeters. Now we will check test current for this multimeter. DC milliampere. This multimeter is using 1 milliampere test current with 2.7 volt, but this multimeter was providing test voltage 0.3 volt with 0.12 milliampere. So here is difference, 2.7 volt with 1 milliampere current. In continuity, 1 milliampere current, but the voltage are 7 volts. In diode mode, the same, 1 milliampere, 7 volt, 7.2 volt, 7 volt, continuity 7 volt, for resistance 2.79 volt, 0.279 volt at 0.12 milliampere. In both directions, the resistor value will remain same between base to emitter. When we test in continuity, the same, 0.12 milliampere. In diode mode, the difference is here, 0.08, 0.09. Test current is 1.6 milliampere. This is the reason that we are receiving different reading. If this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.